to run. Okay, now today's chapter is Form 4, Chapter 3, Chemistry. And the chapter name is about mole, about chemical formula and chemical equations. Now, let's start with step 1 as usual. We have four drawers. We have we have this relative mass system. Drawer number 2 is mole. Drawer number 3 is chemical formula. Drawer number 4 is chemical equations. So let's, as usual, create this main story to help you to remember the name of the drawer in sequence. I have this fat relative of mole. Mole is a type of animal, right? So the fat relative of mole drive Formula 1 to Ecuador. Ecuador is a country, right? So why fat relative? Mass is about weight. Weight is about fat, right? So this fat relative, and the name is relative mass system. So the relative of your cousin, your auntie, your uncle, those are your relative. So this mole family, he has this fat relative, right? Mole is the type of animals, but the mole over here is not the type of animal. The mole over here is a unit of that you need to know for chemistry, equation and chemistry formula. If you do not know it right now, it's fine. You're gonna know it later, right? Then this fat relative, what he does is he drive Formula 1. He drive this very fast supercar to this country called Ecuador. Right? So I think this is clear. Why I put this story this way is because relative mass, mole, chemical formula, chemical equation, right? So let's watch that video quickly. Where's this video? Okay, open this video, not this one. So let's watch this video quickly. Where's this video? Electronics, not electronics. Yep, it's here. Okay, let's watch this quickly.
Form for Chapter 3. Mole, chemical, formula, and equation. Fat relative of mole. Drive Formula 1 to Ecuador.
Okay,
Draw.
If you have problem on the video, let me know. If no, then we will proceed, right? So that very short story, hopefully will be... Okay, Jing San is typing. You cannot see. Okay, let me share again. Okay, can you see screen now at least? Jing San, you can do it, I think. Okay, now let me try to play the video.
For Chapter 3. Mole, chemical, formula,
What about
and
this
equation.
video? Can you see
Fat
well
relative of mole.
with audio?
Drive Formula 1 to Ecuador. Draw 1. Relative.
Okay, I think you should be able to see it right now, right? With the video. Okay, let's continue. That's good. Jaden, if you have a problem, let me know, because usually you have your internet is not so great, so I don't know why. That's why it created a lot of problems for you to watch a video. Okay. Now we have this step number 1. Step number 1 is done. So let's go to step number 2. Step number 2, I divided it into 4 drawers. I think you can see it as I put the title name as the green color, so it's easier for you to differentiate where is drawer 1 start and where drawer 1 end, and where drawer 2 start and where drawer 2 end, and so on and so forth until drawer 4. Okay, so let's take 2 minutes to read drawer 1 and drawer 2. Drawer 1 and drawer 2, right? If you do not understand fully, that is fine, right? You have to set your right expectation, because you are still in step 2. And step 2 is a very beginning step. Let's start. Hi, Joey. We are reading step 2, draw 1 and draw 2 for 2 minutes, remaining 1.5 minutes. So you can start reading draw 1 to draw 2. Step 2. If you cannot see the screen, let me know. Hi, Xuan. We are in step 2, reading drawer 1 and drawer 2. 1 more minute remaining. If you cannot see the screen, let me know. No problem, Xuan. You can see this. You cannot see the screen, let me know. Okay, I think I'll restart the timer because some of you join, and also I disturb you while you're reading. So let's read again. Draw 1 until draw 3 for 2 minutes. For 2 minutes. 1 until 3. Okay, I will scroll down a bit more here. I'll still give you 2 minutes. Whoever who completed 1 out of 3, you can continue drawer 4. If not, you can read it again, whichever you feel like it. You have 2 minutes. This chapter has many new terms, new definitions, just to set your expectation right. 45 seconds. Okay, right. Now let me just give you a quick brief. What is this? Right, drawer number one is relative mass system. Is a system to calculate the weight of the atom or molecule. You know, your weight, how do you know what is your weight? Whether it's 40 kg or 50 kg or 30 kg, you go to a weighing machine. Even if you want to weigh a handphone, then you have to change to another type of weighing machine that is more sensitive, because handphone, if you put on the normal weighing machine, you will not see the actual or the right weight for a handphone. Let's go a bit smaller. Let's go a weight of ice. How do you weigh it? There's another type of weighing machine, right? So let's go a bit smaller. Atom or molecules. How do you weigh atom and molecules? Right? There's no way to weigh it, because there's no weighing system that is as sensitive as, you know, to be able to weigh the atom. What is your gram? How much gram you have? Right? That's why they have this system called relative atomic mass or relative molecular mass. It's the same thing, but just one is relevant to the atom, the other one is relevant to the molecule. All right. What is atom and what is molecule? If you do not know, um, don't worry. Later you will know it. But just that they are similar, but just one is for atom and one is for molecule. Right. Just like one is for ball and the other one is for table. Right. Okay. Two different things. Right. So that is relative mass system. That is drawer number one. Then mole concept. These are the new definitions or new terms that you need to know. If you do not know it right now, it's fine. Towards step 3 and step 4, you can know it in more details. Then chemical formula. How do we read chemical formula? Right. This chapter is not to teach you how do you create a chemical formula, but how do you read, right? Different symbols or different subscripts or different number ratios, they're having their own definition in it and their own value. Then also equation. Once you form the formula, then of course there's equation, right? So that is about that chapter, this chapter. So let's continue. Let's continue to step 3. Step 3 is reading the summary. So by now, I think you should know what is the expectation that you should set for your step 3. You should be increasing your knowledge from level 2 to level 3, right? And you can see that it is linked 1.1 and 1.1 here, 1.2 and 1.2 here, 1.3 and 1.3 here. The only difference here is this is a very summarized way of explaining what is 1.1, 1.2, 1.3. Step 3 is a more elaborative. So by right, you should have increase in your knowledge. Okay, so let's do 2 minutes for drawer 1 from here, draw 1 until compound. Let's do 2 minutes. Let's start now. All right, let's continue a bit more here. Let's do 1 minute. For whoever who did not finish, you can continue the previous part. But you can start 1.4 now if you want. All right, let me give you a very short explanation. How do they use this to weigh an atom? There are many types of atom. You have hydrogen atom, you have oxygen atom, you have carbon atom. There are so many atoms in the world, right? And hydrogen atom is apparently the lightest. So they initially use hydrogen atom as 1 unit. So if carbon 12, how heavy is carbon 12? You cannot weigh it. You cannot tell exactly it is 70 kg or 20 kg or 1 gram or 0.2 grams. It's so light. So they use relative. So carbon 12 is 12 times more heavy than hydrogen atom. So that's why it is called carbon 12. Or maybe another atom, let's say oxygen atom is, I don't know, I'm just giving a number, 20 times more heavy than hydrogen atom, right? So that is the relative atomic mass relative to hydrogen, right? But now they are using carbon as the base, no longer using hydrogen, because hydrogen is gas in a room temperature, so it's hard to handle. But for carbon 12, they choose it because it is solid. It is a solid state at room temperature, so it is easily handled. So everything from then on is based on carbon 12. So that's why you have this 1 divided by 12. Okay, 1 divided by 12, because carbon 12 is 12 times more expensive than, and no, more heavy than hydrogen atom. Okay, that is the main concept to understand what is this relative mass system. So let's go to drawer 2. I'll give you 2 minutes as well. Let's start now. This one has many definitions. It's a new terms, new definitions. And second, all right. Oh, yes. Before I go down, I'm not sure whether you remember, we attended this physics chapter 2 measurement for Form 4 for year 10. One of the chapter is about about base quantity. Base quantity, there are 7 base quantity. One of the base quantity is mole. So mole is the unit to calculate the amount of substance. Right? You have 7 quantities. You have length. You have temperature. You have time. Then you also have this amount of substance, and the unit is called mole. Right? Let's come back here again. Okay. So I'll give you 1 minute to continue the rest. Don't worry about remembering everything. I'll create a story for you to remember this easier. Molar mass, molar volume, number of particles, Avogadro. Ten more, 5 more seconds. Right, let's go to drawer 3. Let's move on to drawer 3. Chemical formula. Chemical formula. This is, we'll break it into 2 parts also. Right, break it into 2 parts. From drawer, let's do 2 minutes. Let's start a bit slower. 2 minutes for drawer 3 until that table, the first table. Okay, you should be in point 4 by now. Fifteen seconds. Okay, let's go to the second part of this drawer. There are tables. I think I'm going to slow down a bit. Okay, let's do 2 minutes. Okay, I'll go down a bit. Determination of empirical formula. Okay, I'll scroll down a bit more to cover the last part. This chapter is not too difficult, but there are new definitions or new terms that you need to know. Okay. Right. So this is chemical formula, and there are only a few important terms that you need to know: chemical formula, empirical formula, molecular formula, and what is that? I think for now you already have some ideas. Don't expect yourself to have full understanding. If you do, that definitely excellent. If you don't, that is normal, right? Just need to know there are a few formulas like chemical formula, empirical formula, and molecular formula that you need to understand, okay, for this drawer. Now let's go to drawer 4. Let's see how, okay, drawer 4 is just this one small part. Let's do 2 minutes. Let's start now. Okay, you should be in maybe 4.4. Let me just scroll down a bit. All right, 10 more seconds. Now, that's for step 3. Before we go into step 4, I need you to quickly read this again. Draw 1 and draw 2 for excuse me. Draw 1, draw 2 and until 4 for 1 minute. I want you to have the feeling that now you understand a bit more compared to 8:37 a.m. just now, which is about half an hour ago. Okay, let's start now. I'm going to scroll down as we move. Draw 1 until draw 4. You need to have that feeling. What feeling? You understand a bit more compared to half an hour ago. The keyword is a bit more, not fully understanding yet. Okay, let me scroll down a bit to cover that drawer 4. Yep. Okay. If you don't have that feeling, you improve or you have a better understanding, then you have to tell me. All right, but you should, because it's proven by so many rounds already, I think. So now let's not waste more time, or let's not spend too much time on this. Not waste time. Let's do step 4. Step 4 is FAQ, frequent asked question for drawer 1. Now you have 2 questions. Let's do 1 question at a time. Okay, question 1. I'll give you with a bit of introduction about what is this chapter about. Then I'll give you 1 minute. Introduction plus draw 1. If you want to continue on draw 2, you can do it. Oh no, question 2. All right, now question 2. Okay, 1 minute, start now. Ten seconds. If it is too fast, you have to let me know. If you need more time, let me know. You can adjust. Now, draw 1 is done. Your knowledge level for draw 1 should increase to level 3. Level 3. Right, you should have a bit more understanding on drawer 1 by now, since you already gone through step 3 and step 4. Right, so let's build that understanding for drawer 2 to become level 4. Okay, let's do 2 minutes for question 3 and question 4. No, I think let's do 3 minutes. 3 minutes. I'll give you 2 minutes plus 1 minute. All right, 3 minutes. So read slowly. Okay, first minute is gone. You have 2 more minutes. 2 more minutes. Not 1 minute, 2 more minutes. Okay, let's do one more minute. The last minute. You should be in question 4 if you're not yet. All right, this is drawer 2. Okay, Singing left, I saw. He has something to do. He's supposed to leave 15 minutes ago. Right. So, okay, let's continue. Let's continue. In fact, just for your information, Xingling was my first class student, so she attended 2 hours earlier this morning already. We were teaching about electronics, very interesting topic. Form 5, year 11. Right? Okay, let's focus back here. Drawer 3, we'll do the same thing for 3 minutes. 3 minutes. Let me just move it to 3 minutes. Start now. Drawer 3. Question 5 and question 6. Twenty more seconds. All right. So I hope by now you understand what are the key information inside a chemical formula, like the symbol, the subscript, right, to identify the number of molecules. The atom, what type of atom? H is hydrogen, C is carbon, O is oxygen. And then the empirical and molecular formula. What is the difference? Once you read this, I think by now you understand quite well what is the difference, because it's a very simple difference between empirical and molecular formula. Right? It's just whether it is using the simplest whole number ratio or whether it's using the actual number of atoms for each molecule. Right? As simple as that. Whether they're using 6, 12, 6 or 1, 2, 1. All right, they did not mention write down the 1 over here, but it is 1. 1 carbon, 2 hydrogen, 1 oxygen. Right? And that is glucose. Easy, right? It's not as scary as you thought when you first read it. Now it's becoming easier to unpack. Okay, let's do 3 minutes as well for drawer 4, chemical equation. Let's hope you also become easier for you after these 3 minutes. You should be in question 8 by now, if you're not. All right. We are done with step 4. So your understanding level should increase to level 4 for all the drawers right now. Right, before we do the review of drawer 2, step 2, let's continue. Let's continue on another heavy steps, which is the step 5, reading the guides. Right, reading the guides. It is also similar to the format is similar to step 2. Step 2 is having drawer 1, drawer 2, drawer 3, drawer 4. Same goes to guide. And even they're having sub drawers, which is 1.1, 1.2, 1.3. All right, but it's having more details. More detail. That's why it will help you to improve your understanding from 4 to 5 after reading this part. Right. So let's do 1 minute. I think 1 minute is good enough because this is not the first time you read this. So some of the terms and some of the definition is not new to you anymore. So let's do 1 minute for draw 1 until the end. Until the end. No units, right? No units. Draw 1 until no units. Okay, let's do 2 minutes. I think it's a bit too much word for us. So I'm gonna add 1 more minute. Let's read it slowly. Okay, by now you should finish the introduction and go into point number 1. Don't worry, there's 1 more minute extension. Okay, 1 more minute. Okay. All right. This is the first part of drawer 1 only. So we have second part. We also take 2 minutes. Let's do 2 minutes here. Okay, let's start now. Thirty seconds. You should be in point 4 now. Or completed the whole thing. All right, let's move on to drawer 2. Drawer 2. How much is this? Oh, okay. Let's divide it into 2 parts. Divide it into 2 parts. Okay, let's do 1, 2, 3, and part of 4 for 2 minutes. Let's start now. Mole concept, drawer 2, mole. 40 seconds. Oh, Jing Sum. Okay, Jing Sum is back. Fifteen seconds. All right. So let's go to the second part. I hope this is not as scary as it was now. Right, you know what is avogadro? It sounds like avocado. You know what is mole? You know what is number of particles? Now molar mass. Okay, let's do 2 minutes. And I'm going to scroll down to cover the 0.6 as we go along. Right. So let's do 0.4, 0.5. Okay, I'll move down to 0.6. Twenty more seconds. Right. Okay. That is drawer 2. Right. Should we go to drawer 3 now? Right. Before I go to drawer 3, just something crossed my mind now. For Eric and Jaden, if you were asking yourself this question, why are you attending this class now? Because this is a year 10, equivalent to year 10 syllabus, since I think you are year 8. The answer is very simple. You are learning a study method. And in order for you to be familiarized and good in this study method, you need to practice more. So take this as a practice for you to practice this study method, right? By going through step 1, step 2, step 3, step 4, until step 10. At the same time, you are preparing yourself to learn something more advanced than your classmates, right? So I'm sure not many of your classmates know what is mole, what is relative mass system, right? And that I believe it's going to help you in your next year, year 9, science class, to understand some of the explanation from your teacher better, right? So let's go to drawer 3. Drawer 3, they are, okay, let's go to drawer 3. Drawer 3, I give you 2 minutes. I'm going to scroll down as we move gradually. All right. Okay, I'm gonna move down a bit. Okay, a bit more. Right. Okay, 10 more seconds. Then we'll go to the last drawer. Okay, last drawer. Then the heavy part of reading is done. Okay, just bear with me for one more small part. This one will divide it into two parts, right? All right, from drawer 4 until this number 4. All right, here. Let's do 1 minute for this one. I think it's relatively easy. Okay, let's move to number 5. Okay. Number 5, I'm going to scroll down slowly. Let's do 2 minutes. Let's do number 5 now. Okay, I'm going to scroll down slowly. Here. Okay, in case you are confused, I'll give you one way of helping you to understand, to learn, right? For example, you're confused of this point number 5. What I'll do, I do a screenshot, okay? It's either screenshot or you can copy the whole text, open it in, ChatGPT, right? I hope you know how to use ChatGPT. Then I paste it here, the screenshot, explain in a more simpler way. All right, so in a few seconds, a more simpler way of explanation is going to be shown to you, right? So there are this explanation that is being generated by AI to show to you what is that, right? So this is just one example. Any parts in the notes, whether it's my notes or whether it's your notes or whether it's into the textbook, you can do it this way. Right? Any parts you do not understand fully and you want to know more, then you just ask the AI tools. It could be ChatGPT, could be Perplexity, could be any AI tools, Cloud, could be a Microsoft Pilot. Just ask them on the parts that you are not sure and ask them to make it into a more simple way for you to understand. Right? So that is one way to help you to improve how you learn more effectively. Right? So that is step 5. Before we go to step 6, let's do this. I'll give you 1 minute. You read from drawer 1 until here. I need you to have the feeling that you understand much more than 1 hour ago. Okay? Let's start now. 1 minute. All right. Time's up. So if you have that feeling, then excellent. If you don't, then I'm worried. Right? By right, I think you should have that feeling. Reading this compared to 1 hour ago when you read this the first time, and now you read it again, you feel that you know way more than 1 hour ago. And it's only 1 hour, right? It's only 1 hour, and you are able to have this feeling of way more, not just a bit more, but way more. That is excellent. Right. So step 6. Some people like this step, some people doesn't like this step. But this step is important. Right? So let me tell you what is important over here. So there are 4 stories, 4 drawers. Each drawer has their own story. And this story, the objective or the goal of this story is to help you to remember what are some of the key messages or key points that is relevant to this drawer, right? Drawer number 1, or number 2, or number 3, or number 4, right? So that is the story. This story is my story. I created my story because this is very personalized. The objective here is to create some emotions so that you'll be able to have this remember what is in each drawer better, right? Because if I give you this text, you might be able to remember now. I'm sure after 1 day you'll forget most of them, right? But with story, then it's harder for you to forget because human brain loves stories, right? As simple as that. Now, relative says ask mom first when 12 car born. Okay, whatever it is, it's a silly story. It doesn't make sense. It's not logical. It's fine. Okay. Relative says ask mother first. Ask mother first. So relative is relative. Ask is atomic. Mother is mass. Okay, so relative says ask mother first. So you have a relative tell you to ask your mother first. And what is F? F is I put it as formula, right? So you have RAM F. So relative atomic molecular formula. Atomic is us, molecular is sorry, mother, and formula is first. So this will help you to remember there are these three definitions or these three relative mass systems that is taught in this drawer. Relatives ask mom first. When 12 carbon, right? So this is also to help you to remember there is this carbon 12, right? Because carbon sounds like carbon, right? And 12, of course, this representing the 12, right? So I hope this story makes sense. Of course, this is a story that doesn't make sense in terms of logical understanding, but this story makes sense for you to help you to remember what is the key information inside this drawer. Number two, remember I told you I will help you to remember this with a story. So let's do that. Molly avocado produces magic volcano. Right. So Molly, this avocado named Molly produces magic volcano. Right. So Molly stands for mole. So mole is the SI unit. Then avocado stands for avocado. Wait, let me just mute. Okay. Avocado is avocado. Avocado is avocado. Produce is particles. Mass is magic. Volcano is volume. Right. So what is in the drawer number 2? You have something related to M, mole, avocado. There's number of particles. This mole is a SI unit. Then the producers is particles, P, right? So you'll be able to calculate the number of particles by multiplying mole by Avogadro constant, because 1 mole has this approximately 6.02 to the power of 23 particles, number of particles, right? So that is Avogadro constant. Then magic is molar mass. Molar mass, this is the formula. Okay. Then the volcano is volume. This is also the formula, right? So let's go to then the relationship. I did not put it inside the story, but I think by now you should have some understanding what is this relationship between particle, mole mass, and volume. If you don't worry. You still have your ChatGPT, right? Just copy or screenshot and send it to the ChatGPT and ask them very simple. Tell me or explain to me in a more simpler way. Then it will explain. I'm sure by reading these very long explanations, but it's a very simple explanation, then you'll be able to understand more detail, right? So it's not only this, but anything, any subject or any chapters, you can do the same method. So everything is about method, right? Drawer 3, chemical formula. Chemical formula, you have emperor. This is also a story. A story of emperor for monkey. Ask many monkeys read formula. Right? Emperor's monkey, the king monkey, ask many monkeys, many of these monkeys to read formula. Right? So emperor represent empirical. So you know there's something related to empirical formula. Then you have monkey, you have molecular, right? M for molecular. Ask many monkey, right? Many and another MM. MM is the MM. What is the MM? Let me think. Okay, I can't remember now because I created the story of a while ago. Okay, read formula obviously is to read the formula, right? Because you have chemical formula, you have empirical formula, you have this molecular formula, right? For now, I can't remember what is this many monkey. Later, maybe we will remember it as we read. Okay. Okay. So for now, we'll change the formula. Sorry to Empress monkey read formula. Enough. Until we find the read many monkey with the MM. Where is the MM come from? Okay. Empress monkey read formula is also something very easy for you to remember what is in this chemical formula. Right. Now, drawer 3, chemical equation. Re-eggs, punch duck, monkey visit penguin. Okay. React is reaction, right? For equation, there is always a reaction. Then punch duck, punch is the product. There's always a product and there's always a reactant. Okay. Reactant plus the product. Product is punch duck. Sounds like product. So reactant and product. Okay. So because formula equation, you have two parts here, right? The left side is the reactants. The left side is the product. Right. So this is reactants and product. Monkey visit penguin. Monkey visit penguin. What is monkey visit penguin? Let me think. Okay, I'm sorry, I can't remember what is monkey visit penguin. Something related to M, V, and P. Something related to M, V, and P. All right, but for now, what is the chemical equations? You know that there's a reactants, there's a product, right? I think we see it from step 3 and step 4. There's this equation that is having some formulas, right? Some formulas, chemical formulas that it combine to be equations. And there are two parts in the equation. You have reactants and you have products. Let me try to remember what is this monkey visit penguin again, right? Monkey visit penguin. Okay, it's okay. Now, so that is step 6. So let's watch the video and let's see whether this will help you to remember the story.
Form.
Okay, whoever who cannot see the video or cannot hear the video, let me know.
For chapter 3, mole, chemical, formula, and equation. Fat relative of mole. Drive Formula 1 to Ecuador. Draw 1. Relative mass. System. Relative says ask mother first. When 12 car born. Draw 2. Mole. Molly avocado. Produces magic volcanoes. Draw 3. Chemical formula. Emperor monkey. Asks many monkey. Read formula. Draw 4. Chemical equation. Re-egg punch duck. Monkey visit penguin.
All right. That is this one. That is step 6. That's step 6. Okay. Now, let's do this step 7. Step 7 is the quiz where we will read the questions, then form your own answer by yourself before you read the answer. Right. Then once you read the answer, identify what is the new information that you do not know or you haven't put it in your answer, and discover that and put it inside your drawer. So we are training two skills over here. The speed of you retrieving, the speed, or do we need to go? Okay, goodbye. The speed of you retrieving your information, and also how fast you are able to identify new informations, right? So let's start by withdrawal one and question one and question two in 1 minute. Let's do 2 minutes first. Question one, question two, and question three. Question one, two, and three. One more minute. All right. Let's do 4, 5, and 6. 4, 5, and 6. Okay. 2 minutes. Ten more seconds. All right. Let's do 7, 8, 9, and 10. I did not. 2 minutes. Let's start now. I did not name the drawer. I'll do it later. 30 seconds. I remember it's monkey visit penguin already. Later I'll tell you. Okay, let's continue on this first before we go to the monkey visit penguin. Okay, now the easier part. The hardest part is all gone.
Welcome back to The Explainer.
If you cannot
Today
watch
we are embarking on a truly
and
fascinating
also hear
journey.
the video,
We're
let me
going to
know.
take the invisible,
Okay,
mind-bogglingly tiny world.
Okay, I believe you can. If you cannot, then let me know, okay? I'm playing a video now. It's about 8 minutes and 30 seconds. Let's start now.
Welcome back to The Explainer. Today we are embarking on a truly fascinating journey. We're going to take the invisible, mind-bogglingly tiny world of atoms and connect it directly to the macroscopic, real-world chemistry that you can actually see, touch, and even taste. I mean, think about it. How do chemists weigh something they can't even see? How do we write exact recipes for chemical reactions? Well, by the end of this explainer, you're going to completely understand the hidden mathematical engine that drives the physical world all around us. Okay, let's dive into this and map out our progressive journey. First, we'll cover the relative mass system. Second, we'll tackle the mole concept. Third, understanding chemical formulas. And finally, decoding chemical
These four are exactly our drawers, right? If you remember our 4 drawers.
equations. Section 1, the relative mass system. Right off the bat, chemistry presents us with a major practical hurdle, the problem of measuring the unseen. I want you to just imagine this for a second. Have you ever tried counting the number of rice grains in a massive sack of rice? You'd literally be there for years. You can't just pull them on. It's a sheer impossibility to count incredibly tiny, abundant objects individually. Well, just like that sack of rice, atoms present the exact same nightmare, but on an infinitely smaller scale. Atoms are far too small to count or weigh directly. You can't exactly put a single carbon atom on a standard lab scale, right? So, how do chemists overcome this? They don't try to find the actual mass at all. Instead, they use a relative system. They compare the mass of one atom to the mass of another atom that's been specifically chosen as a standard. Now, if you're going to compare everything to a standard, what should that baseline standard be? Initially, chemists actually used the hydrogen atom, and it made sense at first, because it's the lightest atom, so everything else was just compared to it. But this encountered some pretty annoying practical problems. So in 1961, chemists across the world agreed to switch globally to the carbon-12 standard. Why carbon-12? Well, when you compare the two, carbon-12 is a solid at room temperature, which means it handles easily. It combines with almost everything. And crucially, the carbon-12 isotope is 99% abundant in nature. That makes it an incredibly stable, reliable benchmark. So the crucial point is this definition. The relative atomic mass, or RAM, of an element is the average mass of an atom of that element, compared to exactly 1/12 of the mass of one carbon-12 atom. You might be wondering, why 1/12? Well, because one atom of carbon-12 is given a definite mass of exactly 12 units. By taking 1/12 of that, we get a perfect standard unit of 1. It's honestly an incredibly elegant solution to the problem of measuring the microscopic. And the beauty of this relative math is how elegantly it scales up. Step 1 is what we just learned, relative atomic mass, or RMM, for single atoms. But what happens when atoms bond? Step 2, we get relative molecular mass, or RMM. You literally just add the atoms up. For a water molecule, H2O, 2 hydrogens at 1 unit each, plus 1 oxygen at 16 units, gives us a relative molecular mass of exactly 18. And step 3, for ionic substances, we call it relative formula mass, or RFM. It works identically. Take zinc chloride, ZnCl2. Zinc is 65, plus 2 chlorines at 35.5 each, gives us a total relative formula mass of 136. See? The math is beautifully consistent. Section 2, the mole concept. But here's the catch. Relative mass is still just a ratio. It doesn't actually have units. It doesn't tell us how many grams to scoop out in a lab. So, to cross that bridge into our tangible macro world, we need this absolutely mind boggling number, the Avogadro constant 6.02 times 10 to the power of 23. That is 602 hexillion particles. Chemists bundle this massive, staggering number of particles together and call it exactly 1 mole. Just like 12 items is a dozen, 6.02 times 10 to the 23rd particles is a mole. It acts as the ultimate universal translation key. And because of this constant, 1 mole suddenly gives us measurable physical amounts. The relative mass we just learned about magically becomes molar mass, measured in grams per mole. Remember carbon with a relative mass of 12? Well, 1 mole of carbon weighs exactly 12 grams. Water with a relative mass of 18? 1 mole of water weighs exactly 18 grams. And for gases, it gets even cooler. 1 mole occupies a very predictable molar volume, exactly 22.4 cubic decimeters at standard temperature and pressure, or STP. Now, what's really interesting here is how cleanly all of these concepts connect. If you want to find the mass of a substance in the lab, you just take the number of moles and multiply it by the molar mass. If you're dealing with gases, you multiply the number of moles by the molar volume. The mole is literally the central hub. Whether you're dealing with individual particles, grams on a scale, or the volume of a balloon, the mole allows you to translate between all of them seamlessly. Section 3. Understanding chemical formulas. So how do chemists actually use these molar calculations to discover the real recipes of different substances? Well, when analyzing a substance, chemists distinguish clearly between two types of formulas. First, we have the empirical formula. Think of this as the stripped down, simplest baseline ratio of atoms in a substance. For example, CH2 means for every 1 carbon atom, there are 2 hydrogen atoms. But then we have the molecular formula. This is the true-to-life building block showing the actual exact number of atoms. So while the simple empirical ratio might be CH2, the actual molecule zooming around out there might be C4H8. So how do we find that true molecular formula from experimental? It's a simple, logical 3-step process. Step 1, you find the mass of that simple empirical formula. For CH2, that's 14 units, 12 for the carbon plus 2 for the hydrogens. Step 2, we know the actual molecule is just that simple unit multiplied by some number which we'll call n. So we equate the empirical mass times n to the experimentally known molar mass. Let's say the known molar mass is 56. Step 3, you just solve for n. 14 times n equals 56, so n equals 4. You multiply your empirical formula, CH2, by 4, and boom, you discover the exact molecule in your and is C4H8. Section 4, decoding chemical equations. Okay, so we figured out how to weigh atoms, how to count them in moles, and how to write their precise formulas. Now we're going to take everything we've learned and put it into motion. Think about grilling delicious satay, a favorite food among Malaysians, featuring spiced meat skewered on bamboo and grilled. Cooking this dish isn't just culinary art, it is entirely a massive series of complex chemical reactions happening right before your eyes. And this brilliantly illustrates our core concept. If you look closely at glowing red coals, the intense heat cooking that satay comes from the burning of charcoal, and that burning can be decoded into an exact chemical equation. C solid plus O2 gas turning into CO2 gas. It's just a simple line of text, but man, it holds a massive amount of physical information. Let's break down every single letter, number, and state symbol so you can fluently read the story of the burning charcoal and oxygen from the air. The arrow means they react to produce the products on the right, carbon dioxide gas. You'll notice letters in brackets. Those are the physical states. S for solid carbon, G for oxygen gas. And finally, stoichiometry. Because the equation is perfectly balanced, it gives us precise mole ratios. 1 mole of solid carbon reacts with exactly 1 mole of oxygen gas to produce exactly 1 mole of carbon dioxide. With our earlier molar mass math, we could literally calculate precisely how many grams of CO2 that grill is producing right now. We've traveled from the sheer impossibility of counting single invisible atoms, through the brilliant carbon-12 standard, across the bridge of the mole concept, all the way to decoding the heat of a charcoal grill. So I want to leave you with this final thought. When you look at the food you eat, the air you breathe, and the entire physical world around you today, can you spot the perfectly balanced chemical equations and the hidden atomic math making life itself possible? Keep observing, keep questioning, and thank you for joining me on this explainer. See you next time.
Okay, that is step 8. Jing Sam is typing. Let's wait for him. Right. Should we go to step 9? Jingsan, you're saying there is sound. Okay. Okay, that's good. I'm not sure whether you are lagging the message. I just received it now because maybe you are responding to the question that I asked maybe 5 minutes ago. Okay. Let's continue with podcast. It's only 4 or 5 minutes. And let's hope this podcast is going to help you to understand or to
If
bridge
you've ever looked at a giant sack of rice and
this concept that you are confused or you are still not 100% sure, to glue them all together, right? So only 5 minutes. Let's start now.
like tried to imagine counting every single grain, well, you know it's basically impossible.
Right. Yeah, it totally is.
But chemists actually have a much worse version of this problem. Like, how do you count atoms when you can't even see them? So today, for our deep dive, we've got a Form 4 chemistry textbook on the table, and our mission is to figure out how scientists measure the unseeable.
It's basically the ultimate locked room mystery, you know?
Mhm.
Because atoms are vanishingly small, you can't just isolate one, drop it on a digital scale, and find its actual mass. You have to compare it to something else.
So it's less about finding absolute weight and more like, I don't know, trying to figure out the weight of a bowling ball by seeing how many apples it takes to balance it on a seesaw.
Exactly, yeah. That is the fundamental logic. I mean, chemists use a relative mass system. Initially, they balanced everything against a hydrogen atom, since it's the lightest element.
Makes
Right. But working with highly flammable gases on a theoretical scale causes practical issues. So in 1961, the scientific community switched the standard to the carbon-12 atom.
Wait, why carbon-12 specifically?
Well, carbon-12 is a solid at room temperature, so it's much easier to handle. Plus, it makes up about 99% of all carbon on Earth.
Oh, wow. Okay, so we're putting everything on a microscopic seesaw against exactly 1/12 of a carbon-12 atom. And that relative comparison gives us the relative atomic mass, or RAM, for individual elements.
They got it.
And if we add those up for molecules like water, we get relative molecular mass, RMM. But the textbook also mentions relative formula mass, or RFM, for ionic substances. Why do we need a completely different term just because it's ionic?
It really comes down to the physical structure. RMM is for molecules where atoms are distinctly bonded together in neat little groups. But
Mhm.
RFM is used for ionic substances like table salt because they don't form individual separate molecules. They form massive continuous grids. You can't isolate a single salt molecule, so you mass of its simplest repeating formula.
Okay, I see. But here's where I get stuck. If I'm just comparing weights on this tiny imaginary seesaw, how does that help me in a physical lab? Like, I can't measure out relative units on a real-world digital scale.
Yeah, you need a bridge between the atomic scale and the human scale. And that bridge is the mole concept, which relies on Avogadro's constant. It's a massive number, specifically 6.02 times 10 to the 23rd.
So wait, a substance's relative mass magically happens to equal its molar mass in actual grams? Is it just a crazy coincidence that 1 mole of carbon, which has a relative mass of 12, weighs exactly 12 grams in reality?
Oh, not at all. It's a deliberately engineered mathematical tool. Scientists calculated exactly how many atoms it would take to make a substance's relative mass number directly equal its mass in grams.
Oh, that makes so much more sense. It's not a coincidence, it's an intentional bridge.
Exactly. Avogadro's constant was designed to be that universal conversion rate. And the cool part is this works across states of matter, too.
Right, because the textbook notes that at room conditions, 1 mole of any gas always takes up exactly 24 cubic decimeters. But wait, why doesn't the size of the individual gas molecules change that volume?
Because gas particles are spaced incredibly far apart. The physical size of the atoms or molecules themselves is just negligible compared to the vast empty space between them.
Oh, I get it.
Yeah, at a specific temperature and pressure, the volume a gas takes up depends entirely on the number of particles bouncing around, not their individual size.
This conversion tool really changes everything. Once we can measure the exact number of invisible ingredients in human-sized grams or volumes, we can start writing the actual recipes, the chemical formulas.
For sure. And the textbook breaks these into two types: First, the empirical formula gives you the bare bones, most reduced ratio of atoms in a compound, like CH2.
Then the other one.
The molecular formula tells you the actual specific count of atoms in the whole molecule, like C4H8.
And seeing that actual count is what lets us use this in the real world. Which brings us to my favorite part of the book, the Malaysian satay example.
Ah, yes, the satay.
Because when you're grilling spiced meat on skewers over burning charcoal, you're not just cooking, you're initiating a chemical equation.
Absolutely. You're taking solid carbon from the charcoal, combining it with oxygen gas from the air. You have the exact recipe for that fire.
Right, and the symbols and the stoichiometry, the mole ratios, show us how to balance that recipe so no ingredients are wasted.
Which means the difference between a perfectly burning charcoal fire for your satay and a reaction that just fizzles out into a smoky mess.
Definitely. We all want the perfect satay.
But if we take a step back and look at that mathematical bridge we discussed earlier, it gets pretty wild. Avogadro's constant links tiny atomic masses to our specific human concept of the igogram. It leaves you wondering, what if humanity had historically chosen a completely different base weight? How wildly different would our mole of the universe look?
Oh man, a universe where you have to measure your sack of rice on an entirely alien scale. Definitely something to chew on next time you fire up the grill. If you've ever looked at a giant...
All right. Let's do the last part quickly. Your favorite part, I hope. Okay, ask me 10 MCQ 2 by 2. No answer. All right. I will do this same setup, left, right with the questions, right of the question, left with the reference. Okay, let's start. Question 1 was the answer. Question 2 was the answer. Ah. Give a guess. We never learned this in question 1, but give a guess. I know. We'll take this example that we'll ask him to explain to us. Right, this I don't understand this. Explain in simple term. In simple explanation. Right. Question 1. Okay. Screenshot. Let me do it again. Upload. Upload. Okay. Let's see. Okay. Good example. Okay. Let's read this quickly. I'm going to scroll down slowly. You can read now. Let's imagine water is Lego, then water is blah blah blah. Okay, let's continue. All right. I think you understand this. So tell me what's the answer. The answer is 18, right? Okay. Let's do number 2. How many particles? Do you still remember? I hope this explanations for the question 1 is clear. And most importantly, it's not the explanation. Most importantly is how do you use AI to help you to learn. Right, that's the point. Can anyone give me the answer for 2? Jaden, Eric, Xuan, Jingsam? This is supposed to be an easy answer. You have the answer right on the keynotes. For question 1, if you do not understand, you have to let me know, right? Because I think if you're able to read the explanation, then you will be able to understand. If you still don't understand, let me know. C and B. Let me get one more answer from another student. Anyone? Jaden, you were typing something just now. C and D. CCB. What is that? Jaden, Jingsam. Number 2 is D. Okay, Jingsam. C and B, right? Number 2 is D. D. Jaden, is it D? This one? Okay, let's change to D. The answer is B, but I'll change to D so that he'll give me the explanation. So Jaden can read the explanation. Okay, the answer is B because it is having these particles. I think there's not much explanation because this one you need to memorize. The Avogadro 1 mole is approximately this number of particles. Right. So let's go to 3 and 4. Relative molecule RMM is C. Number 3 is C. Number 4 is what about number 4? Eric, you're still with us? B. Okay. I think the answer is C and B. Right, let's see. Yep, Eric, C and B. Okay, why C? Carbon dioxide, CO2, having 12 as carbon, because carbon is 12 unit, right? Then for the oxygen, you have 16, which was the answer for question number 1. So, and you have 2 oxygen. So 16 times 2 plus 12, 44. Okay, I hope this is clear. Then for question number 4, number of moles equivalent to mass divided by molar mass. So we have 12 grams divided by 12 molar mass equivalent to 1 mole. All right. Okay, now next. Which of the following is the empirical formula of glucose? You have to remember what is empirical, right? Empirical and moleculars. If you do not know what is empirical formula, then obviously you will not know the answer. Remember, you have this side as your reference. This is the emperor monkey, empirical. Emperor monkey's story. Anyone? 5 and 6? Eric? Jaden? Jaden, you are a bit quiet today. Is it because of your internet? Or you are still not awake? Which chemical equation is correctly balanced? Number 5 is A. Number 6 is B. Anyone? Any other? Wait, where did I type? 5 is A. 6 is B. 6 is C. A and C for Jing Sam also. Let's wait for Jaden. A. Okay, let's try. Let's see. All right. Okay, empirical formula is just divide the numbers by 6. All right, to get this. Then for question 6, this is the answer. H2 2H2 plus O2 equivalent to 2H2O. All right, so that is balanced now. Okay, 2 more sets. How many particles are present in 2 moles of substance? So 1 mole, how many particles? Then you know 2 moles, how many particles? Next question. What is the RFM of sodium chloride? Right. RFM is relative more molar mass. What is the weight or RFM of ion net sodium chloride? C and B. Anyone? Eric, you are quiet. Give a try. It doesn't matter whether it's a correct answer or a wrong answer, as long as you try. Because we are not in an exam right now. C is question 7. Okay, let's try. C and B. I also think it's C and B. Yes, the answer is C and B because 1 mole is this one, right? If you see here, 1 mole is how many particles? Yeah, 1 mole is 6.02 to the power of 10 to the power times to the power of 10, 23. So 2 moles is times 2. Okay. Right. Question 9 and question 10. Anyone? Jaden. Everyone is quite active. Jaden is also active, but just a bit less active than the rest. B and C. B and C. What about Jaden? Jaden. Jaden is B for the number 1, number 9, I mean, and number 10. Still typing. D. 1, 2, 1. Okay, let's do D. Okay, let's see. Okay, B is correct. I think everyone got it correct. D is wrong. The answer is C. Why is it wrong? Let's see the answer. Let's see the explanation. The equation is as such: 2 mg plus O2, then equivalent to 2 MgO. The mole ratio comes directly from the coefficients. So you have 2 over here, you plug it out. You have 1 over here, and then you have 2 over here. So the correct answer is 2, 1, 2. Right? Simple. Okay? I think this question is this chapter is actually easy, relatively easy question chapter, but it needs more practice because there are some calculation that's in it, and by just understanding the concept without practice, it will not get you to be to be able to it will not make you ready to be able to understand calculation questions. Just like maths, you need to practice. For this chapter in chemistry, you need to practice also with numbers, with calculations, right? But at least now you understand, you know that there is this empirical formula, you know that this molecular formula, you know that there's this mass and molar mass, right? And also some of those key definitions. If you still do not know, just take the notes and copy the part that you do not know and put it inside the AI to help you to explain, right? In the AI era now, this is how you learn. You don't need to go to your teacher and ask, because your teacher might not be 24/7 available to you for you, but AI is available to you. Of course, if you're in the classroom, your teacher is right in front of you, you can ask her or ask him. But if they are not available and you need the answer right now, AI is another a good way for you to understand the content. All right. Thank you very much. Thank you for coming. I think next week everyone will be on summer break, or the week after. So maximum we're gonna have one more session or two more sessions for the international students. Thank you so much. I hope you learned something new today. Right? Don't worry. We are always learning. If you do not get 10 out of 10, it's fine. I think you get 8 out of 10 for Jaden. And maybe for myself, I also got 1 or 2 wrongs. Right? All right. Thank you so much. Thank you. Bye-bye.